So the first hill slope, it's going to be about 650 tons of soil. The soil's coming from near Flagstaff, and they're coming in semi-trucks that can hold 25 tons. So it's just this sort of parade of semis that's coming down the highway across the state to come here. We get about 2 trucks a day just to stay ahead of the curve. And I think right now we can load about 50 or 60 tons per day into the landscape. It's going to take us, 2.5 weeks or something to load the soil. A good size sort of middle-class suburban house is like 2,000 square feet or something maybe. And so we're basically taking 2 of those houses and filling it 1 meter deep with soil. So this is 4,000 square feet, more or less, a little over 3 feet deep. So it's a couple house loads soil. The material that we're loading into the first Leo landscape, it's really dark black. It's the first thing you might notice, and you might think it's really organic, like a rich farm soil in Iowa, but it's not. There's very little organic material in it. The reason it's black is that it's a basaltic volcanic rock. And so this is material that was erupted from a volcano, Merriam Crater, northeast of Flagstaff, Arizona, probably within the last 100,000 years. And the material erupted from the volcano. It cooled to sort of these large porous particles. We call it tephra, so this sort of glassy material that cooled in the air and then piled up 100 feet thick up there. There's a thick deposit of this coarse material. It's been ground up to a mixture of sand and silt for this project. And the material, because it's basalt, the minerals that are in it and the volcanic glass, these are among the common minerals on the Earth's surface. These are less chemically stable than many. So they're actually going to chemically alter, chemically weather in the life of the experiment. And so some of the material in here, like volcanic glass, olivine, pyroxene, some of the feldspars, can actually change chemically and turn into things like clay. And so when we see that occurring, that will affect how water moves through. We've ground this to this very even sort of material, so water will flow through really evenly. But in different areas, we'll have clays that are generated, and that will affect how water is retained in between rainstorms and how fast water can move through the system. So the way we're loading the soil, we're going to do 4 lifts total. So each lift is about 25 centimeters. We put in sort of 30 or so centimeters of kind of fluffy soil. Then we run a plate compactor over it, compact it down to about 25 centimeters, and that evens out the soil, so it all has a pretty similar porosity and permeability, and it kind of lowers the speed at which water will flow through it to what we want by compacting it. Makes there less pore space, that sort of thing. And the compactor can only sort of compact so deep, so we do that 4 times. We do it at 25 centimeters, 50 centimeters, 75 centimeters, and 1 meter. And through all this, we have to be placing the sensors and the samplers at the right X, Y, and depth location. In each hill slope, there are about 1,800 sensors or samplers. About 1,100 of those are sensors, which means they're actually electronic devices that make a measurement and send data out to a system. The other several hundred are either water samplers or gas samplers, and these are passive devices that you apply a suction to them to draw out either liquid water or gas from the soil, from a location within the soil. But this part of the project was one of the unknowns, and part of the reason I think there is a little bit of anxiety about how this would go is that this is the part of the construction where the construction folks, the contractors and subcontractors have to work directly with Biosphere 2 people to make this happen. Biosphere 2 is doing the instrumentation, the sensor placement. We have specifications for how the soil goes in, and we're doing a lot of hands-on work alongside these folks, and that's not customary in sort of a contractor-customer relationship. So we've talked about the plans for how this would go. We've had a lot of ideas about how it would go, and in the end we realized that it was going to take a lot of manual labor, and I think it's going really well. Our plan seems to make sense, and by moving the stuff by hand, by placing the sensors by hand and moving the sensors out of the way when we need to compact the soil by hand. It's actually pretty efficient. We had no idea how long this would take. We sort of had this 2 weeks to 4 weeks to 6 weeks idea, and I think we're all really pleased that it looks like in just over 2 weeks we'll be able to get all the sensors, all 1,800 sensors and samplers in place, and get the soil in at 4 different lifts that each one needs to be compacted in about a week, or in about 2.5 weeks, a little over 2 weeks, something like that. So it's very exciting to see this take shape. So as I mentioned, this part of the project was a little bit unknown in how it would go, and how we're doing this is, how we're doing this is interesting. We've got a few different companies involved, and Biosphere 2 is involved. Lloyd Construction is our lead contractor, and they're doing a supervision of everyone, and they've got some of their crew and their laborers working. We've got Magnum Paving, which is a local company that's used to sort of, paving parking lots and doing that sort of work. This is very different for them, and they've got some of their workers here running the equipment, pushing wheelbarrows, helping us run the compactor. And then we've got Biosphere 2 faculty like myself and technicians, Whitney and Dave. We're actually doing all of the sensor placement alongside these subcontractors. So it's a little bit of a dance for all of us to find our roles and keep moving along so we can get this done, but also get it done correctly. So we're really pleased in how it's going so far.